a research that's coming out of Carnegie Mellon's biomedical and material science departments by Dr. Adam Feinberg and his team. I don't know if you knew this, I didn't know this, but apparently printing soft polymers has been like a really hot topic for the biomedical engineering realm. And there's been a lot of issues because the material is soft in itself, it can't support as it's printing and going up, so the full design is never accomplished. To remedy this, Dr. Feinberg and his team came up with a new method called Freeform Reversible Embedding of Suspended Hydrogels. That's fresh, if you were wondering.
That is so fresh.
I knew you'd like it. So the idea behind fresh is that you can take a hydrogel, use standard 3D printing techniques, and inject the soft polymer all throughout to get the design that you want. And the hydrogel is going to do the supporting job in this technique. So once you're done printing, you take it to another station, and you want to take that the soft polymer and actually make it a solid object. So they used a UV light to treat the material and accomplish what they wanted to do. And then lastly, you want to melt away the hydrogel that's been doing all the supporting using some sort of heat source.
So let me see if I've got this right.
Okay.
They've got this Bioink, which is the precursor material to the soft printed tissue that they want to make as the end result.
Right.
And they have this gel that supports the Bioink, so when they inject it in, the ink's not sloshing around or moving or anything, so it stays where it's supposed to be. Then they shine a UV light on it, which helps the Bioink turn from liquid to the squishy tissue-like substance that we're looking for. And then they use heat to melt away all the gel that was supporting it, and then they're left with their 3D printed heart or kidney or whatever their goal was to print.
You got it.
Awesome.
And now, this is what I thought was probably the most interesting part, is the bioink they're using is called Alginate. Alginate is derived from seaweed, and seaweed is, one, very easy to grow, it's cheap, it's good for the oceans, and it's good for the environment because it helps getting rid of some of that excess carbon that is in the atmosphere. So that was really cool to see. And now moving on to the actual application of it, apparently surgeons have been 3D printing hearts using MRI scans. It gives them a better idea of what they're going to be working with, and they can kind of show the patient and walk them through. But because more often than not, 3D printing materials are pretty tough, they can't really get much practice. Now, Dr. Feinberg and his team with this research have completely changed the game. They can 3D print hearts, show it to the patient, and the surgeon can get some practice. Like they can print like 3 or 4, kind of run through what they want to do and see if there's any complications that they think is going to happen, and then catch it earlier on. Before they open you up, they actually can do the surgery like a mock surgery to make sure that they're going to do the best job possible.
That's really interesting. I didn't know that, I guess it makes sense. When you go in to get a really critical surgery, they take enough MRIs of you that they should be able to piece it together and make the 3D model.
Yeah.
So it makes sense that now using this technology from Dr. Feinberg and his team, they can 3D print a soft heart that is not only the same shape as your heart, but also a similar consistency with the tissue. That seems like a great way for these surgeons to practice.
Absolutely. Absolutely. And now, another thing to point out is that these organs actually aren't functional. But both the MRI and the 3D printing technology, they've been able to display that they're pretty accurate. They actually passed some synthetic blood through one of the arteries that they printed. And they made a note that although it's not functional yet, this is a great step towards creating those 3D printing organs that are fully functional, not just hearts, it could be kidneys or whatever.
Okay, so right now their Bioink is based on algae. It's the right material properties, the right viscosity and consistency to be human tissue, but it's not actually living human tissue.
Right.
But their platform will work just as well if we get a good Bioink that we can actually print human tissue with.
You got it right.
That's pretty cool. I think this is interesting. Hopefully I don't need open heart surgery in the next few months, but if I do, I'd feel a lot more confident if the surgeon had practiced on a soft, squishy, 3D printed version of my heart.
I would.
Does this cost a lot? I'd hope that any hospital can access this technology.
And that's the interesting thing. When I was reading this article, I thought that maybe they created some one-off instrument that could do all this. But apparently they just took a printer that I'm pretty sure you can find from Amazon and then did a little bit of tweaking with the software, a little bit of custom hardware. But for the most part, it's very, very affordable. And as I mentioned earlier, the Alginate itself is very affordable as well. So the whole process, I could definitely see this being an equipment that most hospitals can have if they just incorporate this technique.
That's really fascinating, and I think this is a great application of where technology meets human biology and making a